All right, good morning. Today we are going to move on and we are going to talk about how we add linear expressions. So if you downloaded the notes or printed them off, you should be able to follow along exactly with what we're doing. So first thing is we have to know what a linear expression is. And a linear expression is an expression where there's no power that it's being raised to. So an example of a linear expression would be something like x plus 4 because it's not raised to a power. However, if I had one written like x plus 4 to the power of 2, it is no longer a linear expression because linear is going to be able in the future to graph us a line. So remembering that we're only talking about things to the first power will help us as we go through this lesson. All right, so today should be pretty easy. We are going to talk about how we add linear expressions. So if you notice, we had two different linear expressions that are separated from our addition side, and I'm going to add these together. So the first thing I should do before I do any math would be what? What do you think, Elena? Just kidding. All right, first thing we should do is change all of our subtraction because we're just trying to make sure we are in our habits of doing that for when we get to equations next chapter. So once I'm here, I can combine my like terms. So this is just like having x plus negative 3 plus x plus negative 4. So if I were to combine my x's, that would give me 2x, and I can then put my integers together or my consonants. Negative 3 plus negative 4 would give me a negative 7. So that would actually be as far as I can go because I cannot simplify this anymore. I could write it like this. Some of you I know are probably going to have this written as an answer. Those are equivalent to one another, so either would work. All right, let's walk through another one. Again, I have the two linear expressions separated by this adding sign, so I'm going to put together my like terms. And I don't have any subtraction in here, so I can just start putting things together. Again, find those like terms. In this case, I have a negative x and a negative 3x. So if I put these two things together, that would give me negative 4x, and I only have one consonant, so I would be done. If I were you at home, I would pause it and try these two to see if you get them right before I have my answers up here, so you can check yourself. So going through this one, again, the first thing we should do is change our subtraction sign to add a negative. And let's see, Colin, what did you get today? All right. Let's go ahead and combine our like terms. I have negative 2x and an 8x. That should have given us a positive 6x. And then a positive 4 and a negative 4 would actually cancel out. So my final answer for this should have been 6x. Moving on to number 4. How funny is that? Again, first thing we should do is change this to our add a negative. Okay? And combine common things. Negative 4x and 5x would give us 1x. And a negative 1 plus a negative 3 would give me a negative 4. I could have it written like that. If I had it written like this, question is that the same thing? And hopefully you would all tell me that those are the same thing. All right? We can then move on to a couple story problems or a couple word problems. You will have to be able to find the perimeter of a shape using expressions. So if I told you a rectangle has a side length of 5x minus 1 and 2x plus 1, I could draw my rectangle if I needed to give me a picture. And then we hopefully remember how we would find perimeter. If I'm finding the perimeter of a rectangle, how many sides should I add up together? Emmy, what do you think? Good job, 4. So opposite sides are equal. Hopefully you remembered that. So I could write this as 5x minus 1 plus 5x minus 1 plus 2x plus 1. Oops, ignore that. Plus 2x plus 1. And again, make sure I change my subtraction to add the opposite and combine our like terms. 5x plus 5x plus 2x plus 2x would give us 14x. And then I have a negative 1 plus a negative 1 plus a 1 plus a 1. So that would actually end up canceling out. And I would get 14x as my perimeter. We can then plug in what our 5.4 would be in order to actually solve our perimeter And we could go back and do it up here, or it'd be easier to go ahead and put that into our simplified answer. Okay? And that's how we would solve that one. Any questions? Good. All right. There is another example if you want to pause it and go ahead and try this one on your own. Otherwise, we'll call that a good lesson. If you have any questions, email me, or you can reach me on Google Hangouts. See you later.